How will you carry out the following transformation? Mechanism is not required. So I can see that I have a cyclohexane ring here and I have a ring over here also, so I won't count that. I will look outside. I have the methyl group here and the methyl group here. And then 2 carbons here and only 1 carbon here. So it means that I lost 1 carbon. Okay. So if I lost 1 carbon, it means that I have done some sort of an oxidative cleavage, because that is how we get rid of carbons right now. So oxidative cleavage. So oxidative cleavage can be done on alkenes or alkynes. Okay, so here we need to think about whether we are doing it on an alkene or an alkyne. Well, to do that, first maybe we should look at what we have as far as our product is concerned, because in the product we can see whether we have an aldehyde or an acid. Okay, and so when you're looking at your product, you can see that you actually have an acid. So if we have an acid, then we did a higher level of oxidation. So which means that we either need an alkyne or we need KMNO4. So then we look at our starting material. Okay, and I'm trying to just kind of clean this up a bit so we can see nicely. So in the starting material here, we have 2 bromines. Okay, the 2 bromines tells us that we can actually do 2 eliminations. If we just had the 1 bromine, then we would do 1 elimination to get the alkene. But because we have 2 bromines, we can actually go ahead and do 2 eliminations in order to get an alkyne, which is perfect because alkynes can also give us acids. All right, so this is what we can do. So here is 2 carbons then. Okay, so which means that this is the kind of product we will get. And then once we have this, now we can treat this one. Now you can treat this one with 2 reagents. Okay, you can do ozonolysis on this, or you can use KMNO4. Which one you prefer, it's up to you. Ozonolysis is fine. It's not as powerful as KMNO4. But it'll work great. Okay, and so with an alkyne. So now I need to figure out how to go from the dibromo to the alkyne, and that is 2 eliminations. So which means I can just write excess of sodium amide. Okay, over here, excess of sodium amide means that I'm using enough to eliminate both the bromines, okay, in there. So once I've eliminated both the bromines, I get the alkyne. After the alkyne, I do ozonolysis and I get the acid. That also, and then I also can form, I mean, I can write that, I don't really have to because it's not part of the product, but this carbon is going to go away, right? So you actually lose carbon dioxide, okay, in the process. So anyhow, those are our reagents. So not a very long synthesis, okay?